Our team is distributed all over the place. As you can see, I'm in a hotel room in Colorado, right outside of the Rocky Mountain National Park, and I believe Haidai is in Netherlands, and we also have team member from that are in China, in Hong Kong, and in Singapore. So anyway, so we have 3 topics that we want to cover, and so let's get started. The first talk, Haidai is going to talk about what to expect for WasmEdge 0.14. Please, Haidai.
Hello, everyone. Can you guys see my screen now?
Yes.
Okay, great. So I'm doing the WasmEdge 14.0 preview, and actually this version is contain lots of major features. First of thing is that we always integrate the latest LlamaCDP plugin, and we will still maintain a special branch called 13.5 GML branch, which will continue update the LlamaCDP plugin for the 13.5 versions. And we have another release is based on the 14.0. The reason is that we do lots of the plugin API upgrades during the 13 and the 14 version. So they are not compatible. That's why we have to, maintain the dual version for a while. And then we hope that everyone can go forward to the 14 version. And yeah, so this is the first highlight. And we support lots of, huge and important WASM proposals in this version. So first is that we fully implemented the typed function reference proposal. And also we do the exception handling proposal, including the older one, which is used by the Golang, the Kotlin compiler for now. And we also support the latest exception handling proposal. So when these toolchain are updated to the latest version, then we can just support them smoothly without any issue. And I'm very happy to say, it's been a long time. We talk about that we want to have the WasmGC support in WasmEdge, and finally we got it work. So you can use the Kotlin compiler to compile your program and run it with the WasmEdge 14.0. Yeah, and we also have initial JIT execution support, and this version is based on the LLVM framework, and we still have a plan that is to create our own own customized version of the JIT, but it will not ship in recent. We will still working on it. And now WasmEdge will have 3 different execution model. The first one is the very slow one, but it can make sure that every feature is implemented correctly. This is the interpreter mode. And we have the JIT mode now, and also the ahead of time compilation mode. So we have 3 mode, and it will all support in the 14.0. And we have some initial support for the component model, and we are going to have more support in the 40.1 version. So it will just work in progress for the whole component model proposal and also the preview 2 proposals. So there are lots of the CAPI has been changed because that we these new types are introduced by the new proposals. So that's why we have to update and replace the original CAPI with the new one. So when these changes being introduced, you have to update your CAPI, you have to update your Rust SDK for the the latest version. And also we have lots of related API are changed. You can just read the change log, and we have the migration guide on our document side. So when you going to update the WasmEdge library, you may need to check the details and some of the functions, the APIs you have to change. Yeah, and yeah, more more API changes. So please check the change log for the details. And yeah, this is for exception handling. Yeah, but lots of the tag type are introduced, so you can just use these different types to to trigger or to leverage the Watson exception handling proposal. And then we have some helper functions. Now we have the byte create and wrap and delete API, so you can control the buffer easier. Before this, you may need to just allocate 32 bytes integer or something like that. And for now, you can have easy way to control the detail buffers. And also, we have some experimental support for the WASM module serialization, and you can use this function to serialize a loaded model into bytes. Yeah, so we believe the serialization and deserialization will be on our roadmap, and we will continue to maintain it. And one thing is that thank you for the somebody contribution. When you run the WasmEdge tools, now you can see how many plugin is loaded and what version it is with the version option. So you just type WasmEdge -h version, and you will get the WasmEdge version and all of the plugin it detected on your systems. Yeah, so that's all of my 14.0 preview, and we hope we will have this release soon. Actually, at the end of this week, we will have the final RC version release, and if there is no more bug or no more issue are found, then we will just have an official release for this version. Yeah, so that's all of my presentation. Thank you, guys.
All right. So yeah, so I personally think it's very useful to have the plugin version printed at the from the command line, because that's we had a lot of confusions because of our large language model GGML plugins are updated so fast. That's it's updated essentially a couple times a week, and while WasmEdge itself is always at 13.5, right? So I do have another question that I may ask on behalf of the community. One is so you're talking about a lot of API changes at the C API level. So I understand the a lot of the SDK integrations would have to be upgraded in order to use the features at 0.0414. What about today's WASM application? So if I have an application that already compiles WASM and I just want to run it on command line, do I need to recompile it, or do I need to do anything to make it work?
No, this is backward compatible. I mean, in the at the WASM level. So even we introduce lots of the something like the type of function reference, the exception handling, and the GC proposal, you can still run the existing WASM application without any issue, because they are all compatible with the new proposals. Yeah,
that's excellent. So the breaking change is so I just want to clarify, the breaking change is mostly like in the integration and SDK level. It's not at the WASM level, right? So
yeah, that's correct.
Okay, great. Yeah, so believe I saw the Kotlin maintainer here today. That's and he's he's really looking forward to the WasmEdge GC proposal. So I think that's it'd be great that we can have all those available in next version. So what's a estimate? When are we going to have it?
I believe at the end of this week we will have the RC release, and we will need to check with the coding team to see that if there is still any test from their side cannot pass on our version, and if everything works fine, then we will have the official release next week.
Sounds good. All right. Okay. Well, thank you, Hadai. So I'm sure we all looking forward to it. So I guess the next task would be me. Well, so if we have additional questions about this, feel free to ask them in the chat, or ask them in person at the end of the talk. So let's move on to the FX mentorship proposals. Let me share my screen. So since this talk is going to be recorded and published on YouTube, I guess that's so I will speak generally, because a lot of people in the community that's not in this meeting are interested in this type of opportunities. As many people know, that we are very active participants of both the LFX mentorship and OSPp and the Google Summer of Code. So we have a proposal that was accepted by this round of Google Summer of Code. But for the LFX mentorship, we have 3 opportunities every year, and each opportunity we typically have 4 proposals. We aim to recruit new developers or graduate students that has worked out very well for us in the past, or strong undergraduate students as well, who's interested in building up their resume and learn new technology. And so we have fairly self-contained tasks that ask developers to it's typically cover a wider range of skill levels and interest. So we ask developers to complete those, and at the end of the internship, we ask them to merge their features or new projects into the WasmEdge repository, so to become part of the CNCF organization, right? So the best way to look at our the available proposals that's that we currently have is to just start WasmEdge and WasmEdge. I'm sure you guys all have done that, and go to the issues and look at the labels, FX mentorship. You can see 3 of them at the top of our issue tracker. There's another one. Like I said, it's 4 each, right? So those goes from June to August 2024. So it started next month, right? So there's an application process. We're gonna talk about that in a minute, and and then the 4th is lower on the list. I'm going to talk about that in a minute as well. So there are so a variety of different proposals. So let's just go through them one by one. So if you look at this, it's 3 months proposal, and what this one do is that it's not a coding per se, so this one I think is excellent for someone who's interested in, say, spreading the knowledge and promoting, interested in education, mentoring, and tutoring, and things like that. So the goal here is that, the background of here is that if you go to any of our issue trackers, you can see we have a automated issue review, which is we hook it up with GPT-4 to review all the code that's submitted to us, right? We also have another application called Learn Rust that allows people to ask questions about Rust and submit code about Rust, so that it go look up the official documentation and try to figure out recommendations and things like that. With the advance of new large language models, especially with Llama 3 and such, there's new ways to do this. So we want to reorganize the material that we have organized in the past to build them into, say, chapters, and then Q&As and code examples. So essentially, to take the open source Rust documentation and the language reference book, the Rustlings exercise, and things like that, and organize them into a format that can be easily consumed by, say, vector database. So it's still a markdown format, but it's organized in a very particular well, in a particular format, right? So that it can be easily consumed by vector database and large language models. And based on that, we want to fine tune and train new applications that would leverage open source models instead of GPT-4 to answer those Rust questions. So this is not something that you need a ton of programming experience with. If you're just learning Rust, I think that'd be an excellent opportunity because it forces you to go through the entire Rust language reference and things like that. Makes sure that you go through all the examples and understand why this is wrong, why that is wrong, and things like that. So I think this would be excellent topic for someone maybe even in the higher stage of undergraduates and who has a moderate exposure of Rust. So that would be one. And another one is we want, as many of you know, that we have a project called LlamaEdge where we created a whole suite of large language model applications, and one of those applications, which closely related to the one that I just mentioned, is what we call a RAG application, meaning that you have a knowledge base that's stored in a vector database. So when the user asks a question, it searches the vector database first and gets relevant context, and then asks the language model using the context and the user question, right? But there's in the market, there's a lot other ways to do it. So for instance, people say, why do I have to search for a vector database if my question is open-ended? The answer may well not be in a vector database, but it could be in Google, right? So can I change the workflow? So instead of searching the vector database, I search Google first, and then have the Google answer as a context and have the large language model answer based on that. For instance, if I want to ask, I think half an hour ago, Apple has just announced the M4 chip, right? So if I want to ask what's the key features of M4, I'm sure it's not available in any of the pre-made vector database, but it's already on Google. So so that's so that would be an excellent use case, where the question was sent to Google first and have the context and have the large language model answer it, or within the context of API server. So all the interaction is done through API that is OpenAI compatible, so that all the OpenAI applications can be can be substituted with this LlamaEdge server, right? So we already have the RAG aspect of it. So it's called RAG API server. It's listed in this issue, and if you are interested, we would ask you to build that server and make some changes. That's to prove that you are familiar with LlamaEdge, WasmEdge, large language model, and Rust and all that, right? Because the job is really to make changes to the RAG server so that performs a web search instead of a vector database search. Right? So this is another one, which I think is also fairly easy because it's a completely existing database, existing code base. You just need to make some changes, right? Then we have this support Piper as a new backend for for WasmEdge. So, one of the most successful thing that we did with WasmEdge is that we have a plugin called llama.cpp. So we took the C++ project llama.cpp and turned that into a set of WasmEdge host functions, and then allows people to write WASM applications that does large language model inference, and does it in a way that is cross-platform. So the same WASM application can run on a Mac, on the Apple Silicon, and on Linux, on NVIDIA GPU, and all that, right? So it's so that has for at least for us a very popular and tremendous payoff. So what we want is to build more backends, go beyond llama.cpp, so that WebAssembly can act more like a compatibility layer, so that you can write application that's only to the WASM standards, and then when you compile to WASM, it will be able to not only run different hardware, but also run on different software drivers. So meaning that not only have CUDA and the llama.cpp, Mac and the llama.cpp, but you can also have things like other frameworks. So in this, there's a text-to-speech system that's called Piper that we want to incorporate. Again, this is something that you can directly refer to our work with GGML and llama.cpp and look at that code base and understand how the host functions are implemented and integrated with C++ based projects, right? And with that, it would be fairly I think straightforward, but I guess it's harder than the previous two proposals because that does require you to know the inner workings of the the WasmEdge system and be familiar with both Rust and C++, right? So, and then there's another one, the last one, which is a early proposal. Let me, sorry, here we go. So this is issue 3209, and it's down on the issues list because we had this idea a little earlier. So the way that we currently use llama.cpp is that we only use the inference features, which is, I think, the vast majority of use cases. But as we have more inference users, there's people who ask about fine tuning, because fine tuning interface exposed in WASM, you would have the same benefits of, say, the cross-platform, the ease of use. So you don't have to compile the C++ code and things like that. There are just a lot of benefits, and but it's also there's a lot of API functions that you have to hook up in order to support fine tuning through a WebAssembly interface. So that's what we're gonna. So that's the essence of this. This mentorship opportunity is to enhance the work that we have done with llama.cpp, add more API functions, add more connections into the WASM system, so that so that at WASM and Rust level we can support fine tuning, right? So that's so those are the 5. So let me see the So I guess the relevant question really is that is there a fine pretest? So we have in the past, we always have a pretest that ask people to come up with some solve some programming issues, but there has been a lot of issues with those pretests. So for instance, they are very easy to copy. So someone published their answers, and then a bunch of other guys has similar answers, and then how do you judge which one is which, right? And then our experience at Google Summer of Code is that they don't have pretest, but they have a more holistic view. That's so they would engage the applicants privately or openly on the forum, and then judge them based on based on different tasks or question and answers, and things like that, or the quality of their proposals. So that's pretty much what we're going to do. So some of those issues may still have a pretest, but I think for things like coming up with a knowledge base for Rust and the search-based API server, and in particular for that tool, I don't think we will have a pretest. We would just if you're interested, you can submit a application directly, or you can come to our which we would recommend, come to our GitHub issue and chat with us first, right? Just tell us your experience about building WasmEdge and running the relevant projects that are listed in those issues, right? What problem did you encounter and how do you solve it, and things like that. Or maybe you didn't encounter any problem, and show us the results that you have the application running on your system, maybe a screenshot or maybe a question that you asked, and things like that. So yeah, that's so we are trying to make some changes, not to have say a universal pretest anymore. So yeah, all right. So I guess if there's more questions, let's keep asking them in the meeting chat, and we're gonna answer them at the end. And well, that leads us to the we talked about the RAG application server and the LlamaEdge and all that. And I will pass the microphone to Sam, who would very specifically talk about the RAG application server that we have built at LlamaEdge. So if you are interested in an internship, you could listen out. Sam, please. Oh, let me.
Okay. Can you see my screen?
Yes.
Okay. In this part, I will introduce LlamaEdge RAG API server. So what's LlamaEdge RAG API server? We usually call it RAG API server for convenience. RAG API server is a variant of LlamaEdge API server specialized in RAG applications. This server provides a group of HTTP APIs which are compatible, OpenAI API compatible, and so far supports the latest mainstream open source language models. So first, let's see the architecture of RAG API server. The architecture consists of 3 layers. Okay. The bottom layer is runtime layer. It's powered by WasmEdge runtime, and the middle layer, the orange part, is a library layer. Consists of 3 major libraries or crates. The top layer is we call it application layer. Today we will skip runtime layer. We just focus on the library layer and the application layer in the following slides. So first, let's see library layer. Library layer consists of 3 major crates. The most important one is Llama Core. This crate exposes a group of async and sync APIs. These APIs are responsible for finishing tasks like chat completion, embeddings, and also some RAG tasks. And the second crate is endpoints. This crate defines a group of fundamental data structures. These data structures are very important between in the communication between layers and also the API server and clients. All these data structures can be serialized and also deserialized in the communication. And the third one is chat prompts crate. We use this crate to building prompts. So far, this crate defines 26 prompt types, such as the latest prompt type is Llama 3 chat, and also the usually commonly used chat ML and other prompt types. The top layer is application layer. In this layer, this layer just exposes 8 endpoints or HTTP APIs. Among these APIs, 4 endpoints are OpenAI API compatible. They are chat completions, embeddings, models, and files responsible for chat completion, computing embeddings, listing models, and also uploading files. And 3 in this layer also exposes 3 custom, or we call it extended endpoints. The first one is chunks, which is responsible for segmenting a text document or Markdown document into smaller size chunks. The create RAG and also retrieve endpoints can be seen a one-click solution. Let's see, create RAG endpoint. It's equivalent to a combination of files, chunks, and endpoint embedding APIs, which is responsible for create a knowledge base from a given text document or Markdown document. Retrieve endpoint is also equivalent to chat completions and plus embedding endpoints. This endpoint is responsible for takes a user query and retains a scored points. It means search context back to the user. Oh, sorry. The last one is a operation endpoint. Just retains some basic information about RAG API server. Okay. In the following 2 slides, I will introduce some 2 commonly used workflows in RAG applications. The first one is how to create a knowledge base. So in this diagram, we can just divide this diagram into 4 phases. The first phase is just send a request to create RAG endpoint to upload a text file. In the second phase, RAG API server receives a create RAG request, then just download the text file and read the file contents from the text. Then just pass the file contents to Llama Core create. Inside the Llama Core create, the file contents will be segmented into a group of smaller size chunks, and these chunks will be sent to embedding models via WasmEdge interface, and these chunks will be computed into embeddings by the embedding models. Then these embeddings returned to the Llama Core, and then Llama Core will sends the embeddings to the quadrant instance, and the quadrant instance will be responsible for saving the embeddings into a collection. This collection is the knowledge base. This knowledge base will be used to do retrieval and augmented generation tasks in the future. Okay, now I will demonstrate this workflow in a use case. Okay, because we want to use a quadrant instance to keep the embeddings. So let's start a quadrant instance first. Oh, come on. Okay, so it's started. The quadrant instance is on 6333 port. Okay, let's check if there's any collection in the in this quadrant instance. So there's no collections in the quadrant instance. So now let's start a RAG API server, and then use create RAG endpoint to just create a knowledge base. Okay. In this this command will start a RAG API server with this model as a chat model, and this model as embedding model, and the service will be exposed on this port. So let's start the server. Okay. So now let's send a curl request to create RAG endpoint, and use this request to upload Paris.txt document to the RAG API server. Okay, maybe you can see this response. This response is a group of consists of a group of float data, and this is just embeddings returned by the RAG API server, And let's see the log. Okay, from here, we can see the whole process created 6 chunks, and this part is the 6 chunks, and these 6 chunks will be used to compute embeddings, and all these embeddings will be observed to the quadrant instance and save to the default collection. Okay, let's check if the default collection has been created in the quadrant instance. Okay, we can see here's here's a default collection. So let's back to the slides. Okay, so the demonstration illustrates the entire workflow, and we see we have already have a knowledge base and named default. It's saved in the quadrant instance in collection. The second commonly used workflow is retrieval and augmented generation. In this part, we can see user can send a question. We usually call it user query, and where a HTTP, this query will be sent to chat completion endpoint as a HTTP request. API server will be responsible for passing the HTTP request and extracting the chat request from the HTTP request body and send the chat request to Llama core. Inside Llama core, the chat request will be extracted further and we'll get the user query context. The user query context will be used to compute embeddings, and these embeddings will be sent to quadrant to do search, to do similarity search, and a group of scored points will be returned to the Llama core. Okay. The retained scored points will be handled further and extract the source context and also the score. This information will be combined and used as a context retrieval context information. This process is called retrieval, context retrieval. Okay, we have chat messages and also retrieval context. Then we merge the retrieval context into the chat messages, and we can get a updated chat messages, and then we use these updated chat messages to build a prompt string, and then the prompt string will be sent to a chat model where WasmEdge interface, and the chat model will work with the chat messages and also retrieval context to do augmented generation, and returns the result back to the Llama core, and Llama core then sent a chat response with the chat completion message, and then RAG API server wrap the chat response as the body of a HTTP response, then send back to the client or user. So this whole this entire workflow is called retrieval, this part, and also augmented generation, and this part. So now let's see a demonstration how to do this workflow with just chat completion endpoint. Okay, we still use the knowledge base. I mean the collection, default collection we created in the last slide, last demonstration. Okay, so okay, let me clear response. Okay, we will send this message. I mean this message, including a system message and also a user question to the chat completion endpoint. And then you can just notice this part. Okay, let's see the result first. We got a response from the how to say, from to the API, RAG API server. So this is the response. Okay, let's see the log. Okay, this is the last step. Okay, from here, we can see this message shows the user query text, namely a user question. And then this user query text will be used to compute embeddings, chunks computing embeddings. So with this embeddings to do a retrieval task, this is the context returned by the quadrant instance. So we can see this is a scored point. This the score, and this is the source text. And with this context, I mean this context will be merged into the system message of the chat request, and then sent. Okay. Then the updated chat messages will be used to build a prompt string, and this prompt string will be sent to the chat model. We used Llama 2 7B chat as the chat model, and then it will the model will to do the inference and to do the chat I mean just augmented generation, and return to the Llama core, and then return to the RAG API server, and finally return to the end user, just this part. So this is the entire workflow of RAG. So let's see who is the target user of RAG API server. The answer is developers. For application developers, who especially who are using ChatGPT as the backend, they can easily migrate from ChatGPT to RAG API server with no changes on their code. And they can also use our custom or extended endpoints to simplify the development of their applications and make their life easier. For server developers, they can also use our fundamental crates used in the RAG API server, like Llama core chat prompts, and also endpoints to build their own API server, maybe like a search API server or other API server, to do some tasks based on large language models. And for library developers, they can also create more complex and powerful libraries based on the fundamental libraries used in RAG API server. So in general, RAG API server provides a group of HTTP request APIs. Some of them are OpenAI compatible. Some are custom or extended APIs. All these, the entire RAG API server is built based on the three major fundamental libraries. These three traits are highly extensible, so they can also be used in other development tasks. And RAG API server also is compiled once and run anywhere. And it also supports the latest mainstream open source large language model. If you want to try other models or your favorite model, you can find in our Hugging Face account. If you don't find it, tell us. We can just prepare it for you. Yeah, that's all. Thank you, Michael.
All right. Yeah. Thank you, Sam. Yeah, that's I think that's a really good comprehensive introduction of the RAG server, the RAG server, because that's a lot of people are using that without knowing what it is, right? And how it works. So anyway, yeah, if there's other additional questions that that we can ask, but I think it's almost up to the end of the hour, and we have another meeting that's coming up in 4 minutes. So so if anyone has questions, you can ask now. Okay, then let's conclude this meeting. Thank you so much, and I'll see you next month.